Right. So I guess this was the last slide which we discussed, right? T-test. So today, I guess we can go over the this program and then try to use this function called t.test and generate a p-value, right? So did you get a chance to run this at home? No? Oh, your exam. Okay. But midterm exam?
No, the exam was supposed to take midterm, but we already had two of the exams.
Which classes?
Environmental.
Because
But then, like, we're supposed to have like 6 exams generally for the class.
but I guess like you have to conduct all the exams before the spring break for the mid-term, right? So half of the term.
I don't think this is a midterm. You know, she told us that the midterm will be the average of our other two exams. So this one now is just a because we're supposed to take exams after some sections.
After some sections, so it's just not with that section.
It's too much. You should you should tell the instructor that.
Seriously, like it's too much. What can we do?
I'm busy work, finishing those.
And the cost, it's so bulky.
Mm.
It's so much.
But I think, yeah, it was reviewed. It's a new cost schedule.
Who is
So
the
press
instructor?
The ones and there's an external professor.
So he visits
Well, she came
on the Zoom. Okay.
So she was one that designed the syllabus. It's too much.
Yeah, in this class, like 2 exams, that's it, done. You don't, because you're just, it's not like one class, right? You also have to take 3, 4 other classes. So
the comprehensive. I think it's because of the nature of the bulkiness of the exam that we're taking exams by exam after the exam. So it's like it's not a comprehensive exam.
Well, good luck. Okay. All right, so let's open a new art program and name it as March 23rd. Save it on your desktop. And after the class, you can upload this file on Git. The first line here you want to make is our author, your name, date, which is 23rd, 2023. Purpose is to calculate t-test. Done? Okay, so last class we so today I'll just go over this program and I want you to understand how do we use this function, because I'll give you one question in the exam for the t-test. Okay, the same program, and you would have to report the p-value. And so there I would ask 3 things from this slide, right? So this would be, I guess, 20 points question. The first thing I'll ask you is to give me this R file, so march23rd.r program file. Second is there is a plot which is coming out of this program, right? So you see that plot function there. So there's a plot coming out of. So I want you to save that plot as PDF, exam2.pdf, and then email me that. And the third thing is I want you to report the p-value which comes out of the t.test function, the last statement. Right? So if you could give me these 3 things, then you get 20, 25 points, right? Full points. But if any of the things are missing, then you'll get some point deductions. All right, so this is like the only slide I have for the t-test. And once we are done with this, the next class we will start with all these types of distributions, right? So what is distribution? What are the types of distributions? Next, it's a new topic. So for t-test, the first statement here, it says that we want to generate two variables called x variable and a y variable. And the idea is we want to compare x and y to see if there is a difference between x and y. Okay, so in this case, x can be, say, grades of classroom A, and B can be grades of classroom B. And how many grades are there for x and y? Each 10, right? 10 and 10, right? Because you're just generating 10 random numbers. So this function here, R norm, as we discussed last time, this just generates some random 10 numbers in normal distribution. Okay, so let's I'll just copy this, copy both these statements, and then I'll go back to my R. I'll paste it here. Let's run these two and see if we get x and y without any error.
So we're not loading any of the library.
No library. Yeah, this program does not need to, yeah, none of the functions need a library. So inbuilt are functions.
Like what is what point, like what I go quote this script. It's like you don't quote anything, just say you just put in the x and y, things like
just put it as x and y. Are you asking, like, do you need to give a name to x and y?
No, like the function. Yeah, what function are you supposed to put on this R script? Like, you know, when we're doing the ANOVA, you say load the whatever, and you put it.
This thing is like we're trying to put in the variables that we're going to be working with. Like
we are creating new variables.
Yeah, like
Okay, so we can just name it like
create. Yeah, okay. Okay, yeah, I got it. So create new two variables x and y.
The R norm, is it like the function already in R? Like
it is a function. Yeah. Why is it function? Why do you think it is a function? Just looking at the statement.
Like, you know, the function is like before, it's just like, it's at the position where the function.
Just looking at the statement.
Why do I think it's a function? Because it's describing normal, it's describing.
No, just looking at the syntax.
Just it's at this side, it's at the right.
No, not necessary.
Wait, why do I think it's a function?
We have discussed this before. Why is it a function? Just looking at the I don't want to understand, like, know what it does, or just something consistent with both the statements, the way it is written.
Does it have to do with how it like in the both? Why do I think it's a function? Because it's x and y, it's used to. No, x and y is not a function. Yeah, I know the R norm itself. That's
why do you think R norm is a function? Good, double quotes.
Yeah.
So if you remember, like, any name, this is just a name. You can write any name, followed by two quotes here, right? Two brackets, right? If you see that, that is a function. But say if you see this is not a function, right? So anywhere in R, probably not in Python, but very specific to R, a name followed by two brackets is a function. Okay, and that's it. So we are using this built-in function, right? So we haven't imported any external library or package. So R norm is just a built-in R function which we are using to generate 10 random numbers. So if I do this, right, I think I had shown you last time, right? If I run R norm 10 on X and R norm 10 on Y, will the values in X be same as values in Y?
Based on this function here.
Why?
I'm seeing that they are the same.
Like sorry, the question is if you run R this for 10 and R this for, because they are independent variables.
So will X has 10 values, right?
Mm-hmm.
Will the values in X be same as values in Y?
Well, I don't, like you said, they are two independent variables. So if you say I don't think it depends. So they can, I don't know. I don't think it's going to be this. I'm not saying, I can't be sure that it's going to be, because it's just picking randomly distributed numbers.
So you say that they will be different. X will be different, Y will be different. You are saying that it would be same function. Yeah. So the answer is it will be different because the function is same. R norm is the function which you're using in X and also in Y. But the definition of function is it is generating random values. So every time you run this function, it will generate new random values. The answer is correct. Like X values would be not same as Y values. It would be different. So anytime you run the same function like twice, thrice, n times, the values are going to be different because it is generating random values every time you use a function. So now let's check what do you have in X and what do you have in Y. Are they different or same? What?
On the same, when you put this X and Y function,
Mhm.
and the question that this thing came out, this function.
Yeah, when I press X, you get 10 values. Then you press a Y, enter, you get next 10 values in Y. Now, if you just compare X values and Y values output, those are different, as we discussed, right? So these are not same. Do we understand what we have done? And why is it different, right?
This is just for X.
No, this is, first is for X. The first is for X, and next is for Y, right? And the values are different. So now you understand why they're different. So we have just,
I think your values are different from ours.
yeah, it should be different. Because every time you use a R norm function, it is going to generate different values. So it will be different for me, for you, yeah, both of you also should have different values. That's just random values, right? But the property is the random values are in normal distribution. So you should not have a non-normal distribution. Values may be different, but they are in a normal distribution. What is normal distribution?
Without outliers.
Yeah, so the curve, bell-shaped curve, bell. So all these points should follow a bell curve. That's it. All right, so this is done. We have created two variables called X and Y. And why are we using a t-test here?
Why are we using it?
Yeah.
I'm trying to check.
Can we use any other test?
To check for
Difference between X and Y. Why t-test?
Well, can we use any other test? Is that the question, or why specifically t-test?
The question is, yeah, why t-test and not any other test? Just combine your two questions.
Well, we're working with, is it based on the variable itself,
We were trying to find two groups.
Two groups.
yeah,
Two groups.
Yeah.
X and Y. That's the only reason we are using a t-test. If you had X, Y, Z, what would be a preferred test? ANOVA. X, Y, Z, W. Preferred test? ANOVA, right?
Yeah.
More than two ANOVA, two t-test. Okay, so that's the reason we are using t-test, because we just want to compare two groups. Okay, so the next statement we have here is we want to plot. So what I'll do is I'll just copy all of this.
I'm trying to like get the function that I want to think of my own and remember.
Yeah, so I'll make some comments. Okay, so the first thing is we want to plot X and Y values. And to do that, the first line here, it just creates a sequence of points from minus 4.5 to plus 4.5.
Comments.
Yes, so two comments, right? And the first comment is why, what is the use of the entire piece of this code is to create a plot. And the first line here says that we are creating a sequence of points. The second line here is we are plotting using a function plot. And then the next two lines here says that we are overlaying X and Y variables on this plot. That's it. Okay, so just copy and then make some notes, and then I'll explain you. Got it? All right. So the first thing which you have to do is you need to create the sequence of points, right? And just looking at this code, right? What do you think this plot is called?
Sequence of points.
Just looking at the code here, from line number 9 to 16. What do you think this plot type be called?
9
Line.
I think it's a normal display. What do you think? I think because of minus 4.5.
So the functions in the plot in your R program are self-explanatory, right? So
Okay, just looking at it.
so the question is, just looking at the code here, What do you think is the plot called?
What we call is
Like, for example, there can be a bar plot
okay.
with bars. There can be a scatter plot with the scatter of points. Or there can be a
Okay, I think this is because it has corners.
it says the code says the type of the code mentions what can density plot is density plot, right? So there are different types of plots. It can be like a bar plot, scatter plot, density plot. Yeah, there are several different types of plot, like Venn plot, right? You know Venn diagram, right? Pie chart, histogram, right? So this is called as a density plot. And as the developer have written the function, right? The name itself, density. So to make a density plot, so what is a density plot, right? So density plot is, just to give you an example, right? So this is your y, x. This is a line, or it's called as a density, right? Because it is giving you density of the numbers in your data. That's the density plot.
Wait, can you please go back again? What is the density plot there? Is it the bell shape?
Yeah, so this structure here, this is called the density plot.
Oh,
This structure here, what do you think is this called?
bar
Bar plot. Bar plot. Bar. Because bars, right? Bar. This is density. Because it is a density of points. What is the definition? I don't know what the density English definition is.
when things are packed together, like the density.
Yeah, density of numbers.
I think the density, like in terms of thickness.
Yeah, thickness, right? Density is the thickness. So if the idea is, if you see this diagram, this is the density plot. This is what you want to make that code.
So would you call the normal distribution the density?
Yeah. This is the normal distribution. So this is
can it take this density plot? Can it look somehow? Can it take another type of?
Yeah, it's like not normal, right?
Yeah,
not,
can it take a not normal?
Something like this? Yeah.
Okay.
So that is also density. So in this data here, we know that our norm has created values which are in normal distribution, right? So we want to generate a normal distributed curve, right? Something like this. And on top of this, you can add your x and y. This is x, okay, this is y, and the original is your sequence of points. So I'll again explain you. So this line here, sequence of points, SEQ function. So this is creating a skeleton, right? So this is creating a skeleton, which is the first line in the background, first line, normal distribution line, that is created by SEQ function.
Which was line?
This line here.
You got it.
This one. The first line, right here. The first line is created by SEQ function. The dotted line is the overlap of x, and the next line here is overlap of y. So first thing you want to create is you want to create the sequence of points. And this is just random, right? So you don't need to have like minus 4.5 and 4.5. You can have 5 and 5 or 10 and 10, right? And the length, you want to add 100 points. So it will make a distribution of 100 points, which are between minus 4.5 and plus 4.5. So I'll just run this and then I'll show you what. So, okay, this statement here, right? I'm running it. And then the next is just a plot statement, plot of these points. I'll run it. And this is what you get. This is your background line, your skeleton, right? The first line. Now, is this normal distribution?
Yeah.
It's a very nice normal, like
Yes.
perfect normal distribution bell curve, right? So the idea is we want to create a skeleton or a background of a normal distribution curve. And on this background, you want to overlap your X and Y. And this plot is called the density plot. Understood so far? You have run this and you get this PDF?
Yeah.
Okay. So the next thing here we are going to do is we just want to overlap. So the data we have is in X and Y, random normal, right? So I want to make density of X in green, density of Y in blue. And if you use a function called lines, then it will just overlap your X on this previous plot. So if you close this plot and then you run lines, it is going to throw you an error.
Oh.
So just remember the sequence. You first have to make a plot function, so it will give you a PDF. Then you keep this plot, right? You keep it live, right? You don't close it. And then you run lines statements here. So let me run this first statement and show you the overlap of green line, which is something like this. Now you see the change?
So now I'm a bit confused because I understand what you say we have overlapping the points for X on this frame. However, when you said X and Y, my mind was going to be we're plotting X against Y. So if we're only using this X, Y.
No, not against.
Oh.
Not against. So I understand, right? X, you wanna do this, X and Y.
Yeah, so that was what I was thinking. So
we want to make a density plot. So this can be done for a bar plot.
Okay.
But we are making a density plot.
So like let's take for example this first number 0.137. How do we identify? Are we just using
137? Where is 137?
0.139 rather?
Yeah, 1394.
Yeah. So where is it on this green? Let's just I'm trying to like
should be somewhere 0. somewhere, I don't know, this is 0.1, 0.0, 0.1, 0.2. The number is 0.139. So it should be somewhere around here, 0.139, 0.1, 0.0.
Just using the X, Y axis to identify this point, like, because I can as well say, oh, 0.139 would be here, because
yeah, you can do that, right? You can plot mark your points on this plot, right? So X first point is 0.1394775. So on green line, you can mark that point. So you know there is this point here for X. You can do that, but this is just a overview of a density plot.
I'm now confused as to how they arrived at. Like, even if you are plotting random, how do you, let's say you are working with some numbers, how do you arrive at like this? How do these numbers give you this particular lines? Because I'm not seeing where you can trace, okay, if we say this is 0.139, I'm not really getting it as to why, okay, can we from there, because if you're saying this is 0.139, tracing from the y-axis, then what value gave on the x-axis gave the y-axis 0.139. Like, is it? It's just the whole like. Why are we, or is all those things happening?
Right. So okay. So just remember for now, a density plot. Okay, I should have explained you this before. So what is the use of density plot? So a density plot is usually used to calculate the frequency. Okay, frequency, how many times a value is repeated. Okay, say for example, if you have your x and y axis, then your x axis can be your number and y axis can be your frequency, which is denoted by q. So how many times this number is repeated? How many times this number is repeated? How many times this number is repeated? This number is repeated, this number is repeated, and then you just draw the line. And this line is called the density. It's the frequency or the occurrence or repetition of some numbers. So that is the general purpose of drawing a frequency plot. In this case, I'm just showing you a plot, which is again a density plot, but it is just showing the distribution of your x variables and y variables and how to do that.
Okay, so this x numbers, like how many times it was repeated? That's what's giving you this x and then this one. So these numbers here,
Yeah,
like probably they're like 100 of
Mhm.
x. Like how many times it's repeated?
Mhm.
That's what's giving you this. That's it.
Yeah, so this is one, right? So it has been, this plot is just showing you the distribution of x points, and you have 10 points, right? And then to compare that, we have made a reference line. So what is the color of a reference line?
Right.
Red. So red is your reference line, 100 points. And green is your x values. How many x values? 10. That's, yeah, just remember that's it. That's for now. Okay. So then we can do the same for your y variables. So now you can see a new line, a blue line, which is for y, right? That's your density plot. So the function of density plot is usually used to check the frequency of your values. And also you can see, right, if there are any outliers. So this y plot here, right? This y blue plot, is this a normal distributed plot?
No, it's not.
There is some, right? So you can also, it should be different for you also. All three of us should have a different plot.
I don't have the normal distribution, but I think it's still some. This is
It's this, they say it like near to normal, because obviously you see like this well, but then you do have some.
Mine was actually that was like this.
Oh, I see. At the top.
It's almost similar to yours. Yes, but mine is like
Right, yeah. Okay. That's fine. So what you know, right? So what you know is you get to know if you have outliers in the data, and then where do you want to focus, right? So, okay, this is like somewhere at the front tail. So probably I can get rid of them because these are not many, right? So compare this big curve with this small curve. So there are not many points. So I probably get rid of these. And then I'll do a replot, see if it has, it's then in the normal curve. So you get to know the distribution and the frequency. Here it's just a simple distribution, but the important function of a density plot is to check the frequency or occurrence of your values. Okay. So that's I think, yeah. So that's all what I want you to know for this question: how to create a density plot for two variables. If I have three variables, right? Obviously, I'm going to use ANOVA. but I want to plot, and I want to see the density of the third variable. How would I do that? And I want to plot it as color red, color purple color. How would I do that?
It's not adding an extra function. Do you think adding I think adding an extra function like density, line density.
Line density is Z color purple.
But then you probably could have created the.
We have to create a new Z variable, right? But you add in additional lines function, you will add up additional curves on your density plot.
So if you just go ahead, just put the line density, the
No,
color, it will give you error.
yeah, because you haven't created, yeah. Okay. So do you think you can make this plot in the exam? So you have to save this, right? So I'll save it here. Save as, let's call it as March. Yeah, PDF. Yeah, March 23rd. Desktop. Okay, so I want you to create this plot and I want to save it as, say, exam2.pdf, and I have to email me that plot to get full points. All right, the last thing here is the t-test. Okay, so I'll just copy the last statement here. Go back to R. I'll make a comment and I'll call it as t-test function. Paste. That's it. All right, so this function here is applying t-test on variables x, y, and the output of this function is stored in a variable called t-test. You can call it as any name. And what are you expecting output from this function? P-value. So let me run this, and make sure you have a dot, right? Don't miss that dot or it will throw an error. Run this, no error. If I just do t-test again here, enter, that's the output you want to get. This output you want to copy, right? You want to copy this output and paste it in this March 23rd document,
The R script.
exam2.rs program, and then email me. So the output here, right? You just copy this, copy, go back to your program, paste it here, and then email me. So I have your output. All right. So in the output, right after the class,
Yeah.
you put it on GitHub, right? Yeah.
You're talking about the
Exam, yeah. And you're not uploading exams on Git, right?
Mhm.
Yeah, because I don't want that to go on Git for my future classes. All right, so in this output, we are just focused on one value, which is your p-value. The rest for this class, we can skip. Okay, there is some confidence value, there is a degrees of freedom value, there is estimates, right? Mean estimates, right? So we can skip that. The only thing which you want to focus is the p-value. So do you think there's a significant difference between x and y variables? Looking at the p-value.
Yeah.
Yes? Why?
Wait, no. Because the values and the p-value is greater than.
Yes. Yeah, it is 0.378 for me. For what is for you?
Yeah, it's 0.38.
0.31.
Yeah, so it should be around 0.3, yeah, something. And obviously it is greater than 0.05. So it's not significant. So we can conclude that there is no significant difference between the x10 values and y10 values. Right? So this is just a sample, but sample data, dummy data. You can put any other interesting data, and then check the p-value. And if it's less than 0.05, then you can say that it's a significant t-test. All right, that's it. So can you generate a plot and a p-value? Yeah, from this in the exam, and you have to practice it.
Yeah, you have to give us.
I'll be giving you, I'll be just giving you, because in this case, we are not importing any data. You're creating two variables. So those two variables I'll be giving you. I'll give you some values for X, and I'll give you some values for Y.
You'll be importing the data.
No. I'll give you this.
Okay, you give it.
I'll give you
10 values.
not 10, it will be more.
The X and Y.
Yeah.
Value N. You can now use this.
So, yeah. So what I will do is in the question, I'll give you, say, 50 values here. Those would be like 2, 3, 5, 6, whatever, till number 50. And then same for Y. You just have to run this statement here. You'll have 50 values for X, and then 50 values for Y, and then do the rest. Yeah.
So you don't need to start doing random, picking randomly. You won't be needing the.
So yeah, I'll give you the values. So I'll just say C, right?
Okay.
This would generate X values, 50 values for X, and then 50 values for Y. Like this. This is what I'll give you. Right? And if you
Although they're all constant, sequence, multiply, multiply, they're all like.
yeah, you can okay, so why are we using 4.5 plus 4.5? Because it fits in this plot, right? But you see this,
There's constant.
yeah, this is constant, this frame is constant, right? The red line here is for 100 points, 4.5 and minus 4.5. But now you see that this green is going above, right? It is cut off, and then blue is also cut off. So you need to increase this frame. To increase the frame, I can use minus 10 plus 10.
Okay, so that's what you mean.
You know what I was the one that I was saying, because when I was seeing the -4, I'm like, are these the values of
Okay, if you want to increase the frame of the.
You can use plus 10 plus, you just,
This length of 100 is the width.
the length is the,
The 100.
you know, when I saw the -4, I was thinking it was like how you have on the y-axis, you have the point of -4 to
yeah,
is on the x-axis rather. Where
yes, 100 points.
Okay,
Yeah,
that's.
on X, you have points between minus 4.5 and plus 4.5.
It goes up more. Increase it to like 10 minus 10.
You just tell, you have to try and test like how difference, you try to fit.
like, I understand if you increase the -4 to.
Let's do
you
that.
want to increase the width and not the.
Let's try. Let me just let me just make it say 10. Let's do 10 and 10. And then I'll just close this. And then we can replot this. Let's see. Copy. Why?
Seriously? Wow.
Why would it give an
The function, the comment,
You know, the comment is in ash.
oh wow.
okay? So
So what you put in the comment.
so it does, yeah, but it does affect the frame of the plot.
A little bit, yeah.
It will skew the plot, right? But that's fine. I mean, even if there is some trim in your plot, that's acceptable for. They're just frame, right? Increase it. But even if you have this, that's still fine. Send me the plot, I'll give you the points. So it takes some it's trial and error, right? So you try 10 point, 5 point, 16 point, 15 point, and then you try to fit in. But I just want you to know the basic, how to make this plot, how to do a t-test, density plot. That's it. And then you can play around with all these different arguments, right? So just change these argument values, change the length, and just the fitting, right? It's just trial and error thing. Okay, I think that should be enough, right? So you should see a question in your exam, 25 points, plot and a t-test. Exam 2. Practice this week. Next week, let me know any issues with this, and then we can discuss again. Okay.
I just said, like, can you go up a little bit? Yeah, like, can practice with this number, like, how
Try practice, yeah. Try practicing with these numbers.
So instead of having 2, 3, 8, you can just put 3 in bracket 50. That's it. What I'm saying, like, the former one you had
and numbers, I'm a bit like, because one of the conditions for t-test, like the normally distributed.
Right, so I'll give you the points, the normal distributed.
Okay, but this one is so.
This is not.
It's not right.
This is not. These are just random. I just want to show you how would I give you in the exam. So this is how I'll give you set of points. And if you want to give you a set of points, then you add a container, right? C, and then in the bracket, you should have all these numbers. So this is how I'll give you. You run these two statements, and you should have your X and Y variables.
I'm saying, the first one, like, the number, like, you didn't, like, specify, like, the number, like, 2, 3, so you just give 10.
Yes.
So what I'm saying, like, but if we're going to practice, like, I was just going to put, like, there are 50 numbers, right? Just put 50 in the bracket, but you want to put this number 2, 3, 5.
So that our norm is going to generate 10 random numbers for you. This function here is what is the user defined numbers, not any random numbers.
Yeah, but are you going to write down the whole 50 numbers?
No, I'm just giving it. No, I'm giving an example of 50. I'm going to give you like 20 numbers, 15, 20 numbers, right? I'm just giving an example, but in the exam, I'll give you like, say, 20 numbers and separated by comma in a container. And you just run this statement, you'll have X values, you have Y values. You don't have to use that R norm function in the exam.
What is this? Okay. So we don't have to use this R norm function. So we're using this C. This C, what does it mean?
C is a container, right? So it's C, it holds, it's the container, it's the bucket. It is going to hold these values within the brackets, and it will make a variable called X. Yeah, just try, run this, and then let me know if you still don't understand, practice, and then we can discuss. All right, so save this and upload plot and R script on Git for your in-class assignment, and we are done. And I'll see you on Tuesday.